Tommy Gartland here again, Dundalk IT. We follow on our last video. We showed how we could get the microcontroller to send messages back to the PC, so that's quite interesting. But even more interesting is when we actually start interfacing with the external world or components in the external world. So in this example here, we're actually controlling an LED, a light emitting diode. There's a program already installed, and there's a built-in LED on the Arduino Uno. Here it is, here. And you can see that it's coming on for 5 seconds and going off for 5 seconds. This LED is actually connected to pin 13 on the actual chip. And so the program is actually controlling the voltage on pin 13 by setting it high and low. Just for comparison, I've shown an actual larger LED on a breadboard here. But you can see this LED is always on because it's just simply connected to ground and 5 volts. So this is always 5 volts, this is always ground. So the pin is always, this 5 volt pin is always 5 volts. But if we take this wire here and connect it over to pin 13, we'll show that the actual voltage is continuously changing. So you can see now I've actually paused the video for a moment and moved the wire connected to this LED also to pin 13. So both of these LEDs, the built-in LED on the PCB and the LED on the breadboard, is connected to pin 13. Now this other LED is just showing any activity on the USB communication link to transmit. So every so often when I turn on the LED, I'm actually sending a message as well. And I'll show that here now in the program. So if we go up here, serial monitor, and now we can see the LED is on, and we can turn the LED on. I'm not sure if I can show both here at the same time. LED is off, LED is on, LED is off. And you can see both LEDs now are going on and off together because they're both connected to pin 13. So how do we do this? Let's have a look at the program. So in our program, we said that we have pins on our board, pins on the chip called, we're referring to them as 1 to 13, digital input output. So they can either be 0 volts or 5 volts. And in this case, we're using the pin as an output because we're controlling something, we're turning on something. We're changing the voltage on the pin in our program to be 0 volts or 5 volts, and therefore we're able to control whether the LED is on or not. So this pin 413 on this chip here, it's one of these pins, is connected to this LED, and you can see also it's connected to the connector here and connected to the external LED here on the breadboard. Internally on our program, we also refer to pin 13, but rather than using the number 13, which we can get a bit confused with all the different numbers, I decided to use a name. So this hash define is effectively what's called a preprocessor macro, where we give sort of an alias or a name to this number 13. So I can use this name now in the program as opposed to using the number 13. You could use the number 13, but then it would make your code less readable. And it's very important to be able to sort of read through the code and understand what's happening, as you can appreciate. The setup function here starts here with the begin, ends down here, so that's the end, that's the begin, and all the code in here is part of the setup function and only gets executed once on reset or power up. We send some messages, we set up the serial link communication rate, we send some messages, and very importantly, we're introducing this new command called pin mode. Pin 13, LED pin, which is 13, is set as an output. So we're setting this pin as an output. Remember, it's a digital input or output, but in this application, for this particular program, we want that pin to be an output so that we can control the voltage on the pin from the program. The loop function then, we send the message the LED is now on, but how do we turn it on? We use this other command called digital write. Pin 13, we're setting it high, which means we're setting the pin to 5 volts, and that's the LED is going to be on. So I just send a message here at the same time. This code is executing very quickly. So we turn it on, we set it high, so that'll seem to happen at exactly the same time, because you could have 1,000,000 instructions per second. So it's very, very fast. Here we have a delay of 5,000 milliseconds, which is 5 seconds, because if we just turn the LED on and off as quick as the program could do it, or the processor could execute this code, then it would just look like the LED is on all the time. So for us humans, we're quite slow, so we have to just put a pause in there for 5 seconds to allow us to see the LED on. Of course, you can change this and get the LED to blink quicker, and an interesting experiment would be to keep reducing the delay and see at what point does the LED seem like it's always on as opposed to flashing on and off. So that would be an interesting little experiment. Then we say println the LED is now off, and then we actually physically change the voltage on the 13, pin 13, which we call the lead pin, to be low, and then we put in another delay of 5 seconds, so we have to put on for 5 seconds, off for 5 seconds, and this is the end of the loop function, which is an infinite loop, and so we just go back around again and keep repeating the same thing over and over again. We check the syntax, you know, everything's okay, you can do that. Upload it, which we just did, and then Tools, Serial Monitor to show us our messages, and then you can look at your board and your LED should be coming on and off. So if you don't have an external LED like I have here connected up to a breadboard, you can simply use the built-in LED on the PCB, and just, you can see from the little experiment that I did to verify that that LED is actually connected the same as the one connected to pin 13. Another few experiments you could do is actually, you know, flash the LED slow, then add a few more lines of code to flash it at a different rate, and then a different rate again. And if you're really ambitious, you could go and, you know, have little for loops here to actually flash it fast for 5 seconds, then flash it slow for 5 seconds, etc. But due to the limited time, I'm not going to go into this now. But if you go to the Arduino website, and go to your reference, and what you really like to look at is an example of maybe a for loop inside the infinite loop. Okay, so something like this here. Okay, so we'll leave it at that. Thank you for listening, and in the next video we'll look at how to use the digital pin as an input, as opposed to in this video where we use the pin as an output. Okay, and see you soon. Bye now.